We're in the pre-algebra chapter, chapter 6, and we're continuing with video number 2. On this, you're going to learn to calculate using your square root key. And so on this, you just need to be able to figure out where your square root key is. On some calculators, you use a second key to get to that. That would be the case with the one that we use for this class. It is second x squared. And then on others, you put the number on the screen and then push your x squared key. For ours, you put it in first. So you do second x squared. And then on your on your screen, you will see this. It'll look like this. It'll open it up. And then you put in your 144. Close your parentheses and equals. Now, I think you can actually just put 144 in and push your equals key and not have to close it. You close it, though, if you ever are doing more than one thing. If you're just putting in one number, it's okay not to close the parentheses. But if not, you must close the parentheses. So if you've got a calculation going on, be careful with that. And so this, you push your equals key and you get 12. Some of you may have already known that answer as it was anyway. So that's a perfect square number, 144. Remember, there are these numbers called perfect squares that start with 1, 4, 9, 16, 25, 36, 49, and we just keep going. So that was 1 squared, 2 squared, 3 squared, 4 squared, and so on. And of course it just keeps going. 144 is 12 squared. So when we take the square root, let me show you that. Because 12 squared equals 144, and we're trying to find out what number did we square to get this number. Taking the square root undoes that, right? It takes the square root of it, and notice it says square root, right? So it's the number that you multiply times itself to get that. On 700, it's not going to come out to an exact number because this is not a perfect square number. So when you take your square root, you get 26.4575. We're going to round this to 2 decimal places. So 26.46. 3,000 is not a perfect square either, so we're going to find the square root of that. And when you take the square root, you get 54.772. I usually just cut it off at some point where I'm not going to have to round that last number, whatever it happens to be. And then that's 54.77. And also enough digits so you can round it, in this case, to 2 decimal places or the hundredths place. Now, these are getting into a little bit more difficult calculations, and I remember in my classes that students would get some of these incorrect. So sometimes you want to calculate some first and not just try to put the whole thing on your calculator. You will find yourself to be much more successful with this if you'll do that. Now, this one actually means 3 times the square root of 20. And so you can enter that in one calculation. That's fine. 3 times the square root of 20. But anytime you have a number written next to a symbol, a grouping symbol of some sort, a parenthesis, square root, whatever, that means multiply. So if I take 3 times the square root of 20, let me make those the wavy equals. It's going to be 13.416. And then we're rounding to 2 decimal places again, so 13.42, right? Because this number tells me I add 1 to that 1. On the next calculation, I would do 3 squared, which is 9 times the square root of 24 divided by 12. And so I would suggest that you just go ahead and do 9 times the square root of 24. Push your equals key to be on the safe side. Sometimes you need it, sometimes you don't. So I just always go ahead and push it to be on the safe side. I don't want to stop and think, do I need to push it this time or not? I just go ahead and do that. Well, if you do that, you get 44.0908. I probably rounded that. Let's see. Whoops. I put in the wrong. There's another root key, but it's for whenever we're doing something besides a square root. Yeah, I did cut that off at the 8 there, and then we're dividing that by 12. You might not want to cut it off on your calculator screen. Go ahead and leave it on there because you're going to be finishing this calculation, right? So once you push the enter, just leave it there and then divide by 12. And if you do, you get 3.674, and we round that then to 3.67. So practice the calculations. You must practice these and make sure that you're okay with them. All right, on this next one, we can square the 5.2. You do not subtract anything here because you have to get this number 5.2 squared, and also it's 3 times whatever's in my square root. So once again, we're not going to combine those numbers at all. So 5.2 squared is 27.04, and then that's minus 3 times 52 minus, you can go ahead and calculate the 5 squared. And then I'm going to do a few more things here before I go ahead and calculate any more. Whoops, I need to write my 3. So 52 minus 25 is 27. And then you can key it in. Like this will work out fine if you just do 27 minus 3. I think even on our calculators, you can just go ahead and put 3 in front of the radical. You don't necessarily have to say times. So you can practice with this and check out, does that work the same? And it does. So if I put in 27.04 minus 3, and then I put my square root, and then close it because we've got some other stuff going on here. We don't want to mess this up. And you should get 11.451, and that will round to 11.45. Whoops, I've got an extra thing in there when we simplify. So practice that square root calculation thing, okay? It is important. All right, so this is a word problem where it's just really about negatives and positives. Now, I prefer that you go ahead and show me what you're doing here. We're adding these up, right? During a series of plays in a football game, the running back carried the ball for the following yardages. So they either gained or lost. Gained 7, lost 3, gained 2, lost 1, 8, lose 5, lose 2, right? We're going to find the total. Well, you're going to just add these up. And so I like to actually see you adding these up. You can write them out with, 7 minus 3 plus 2 minus 1. You can do that way, but I'm just going to go ahead and write it this way. 7 plus negative 3 plus 2 plus negative 1 plus 8 plus negative 5 plus negative 2. Now that did not take very long to write out, and you guys write your work out because it just helps you learn. I can see what you're doing. You make fewer mistakes. So I would just suggest doing that. Now I'm going to add up all my negatives. So negative 3, negative 4, negative 9, negative 11. And then I'm going to add up my positives. So that's 9, 17. So we end up with 6 yards. Now it was the average yards per carry. So let's go back and look at that. There were 1, 2, 3, 4, 5, 6, 7. All right, 7 carries. So we're going to divide the 6 yards by 7, and the average was 6/7 of a yard. Now you can change that to a decimal if you want to. It would be 0.86 if you round it, yards per carry. So don't try to do, sometimes I just feel like people try to, not put down, I don't want to write that much, but in the end, it usually messes you up more than helps you to, speed things up, and then you're getting confused. A vacation trip involved a drive from a spot in Death Valley, 173 feet below sea level, to the San Bernardino Mountains, 4,250 feet above sea level. What was the vertical ascent for this trip? Now, I cannot draw a very good picture here, but we're just going to say, let's say this is sea level, and we started out here at 173 feet below sea level. Maybe that should be down here, right? 173 feet. And then we're going to the top of this mountain that's way up here at 4,250 feet. So it turns out that you're just finding the difference between these two numbers from the top to the bottom. If I write it this way, 4,250 minus negative 173, because it's below sea level, so it's a negative number, we end up adding them. And this is a really common problem for these kind of, when we get to the negative and positive, this is a very common type of problem. So the distance is 4,423 feet for the vertical ascent. So how far did we go up, starting below sea level to way up there at 4,250 feet? All right, so we add them together. This is another very common one, and it's about the fastest 24-hour chill ever recorded occurred in Browning, Montana in January 1916, when the temperature plunged from 44 to negative 54 degrees. How many degrees did the temperature fall? Now, there's different ways you can do this, right? You could just say, okay, I'm going to take 44 and subtract 54 degrees. You have to be careful, though, sometimes on MyLab on how you put these in. And so 44 plus 54 would be 98 degrees is how much it fell, right? Fell this much. I don't want to write it that way. The other way we could do this is negative 54 minus 44. So negative 54 plus negative 44, and we get negative 98 degrees. But it depends on kind of how we answer it. So look at how you have to put it in. Like if you're putting it on my math lab or MyLab, you might put it in like this, or it might say the temperature fell this much, and then we would just say it fell 98 degrees. We're not going to say that it fell negative 98 degrees. So just be careful how it's worded and how you're answering that so that you get that right. All right, so we've got about 3 more problems, and I don't believe I can get them done in 2.5 minutes. I'm going to stop this video, and then we'll have one last video that will probably be a bit shorter than the rest.